Okay, on number 7 and 8, it says to simplify the radicals and tells you to rationalize the denominator if that's necessary. So all that means is if you have a radical in your denominator, you have to do that process to get rid of that. It's not considered a simplified fraction if there's still a radical in the denominator. So on number 7, you are not, I will still have students that will do this, bless their hearts, you are not just putting the square root of 180 in your calculator and giving me that decimal answer. That is not what we're asking you to do. I do not want to know what that equals approximately. I'm wanting you to simplify the radical. Just like if I gave you the fraction 3/9 and ask you to simplify it. I don't mean for you to put 3 divided by 9 in your calculator and tell me it's 0.33333. That's not simplifying that fraction. 3/9 simplifies to 1/3. So we're simplifying the radical, getting it in its smallest form possible. So what you're looking for are perfect square factors of 180. So you're going to separate 180 into two things that multiply to get 180, but one of them is a perfect square. So please don't just change it to anything. I wouldn't change 180 into 2 times 90. That's not helpful. 2 and 90, neither one are perfect squares. So you need to know your perfect squares, okay? 1 squared is 1, but you would never use that as a perfect square factor. That doesn't change anything. 2 squared is 4, 3 squared is 9, 4 squared is 16. You know what I'm doing here, right? 5 squared means 5 times 5, which is 25. 6 squared, 6 times 6 is 36. 7 squared is 49. 8 squared is 64. 9 squared is 81. 10 squared is 100. 11 squared is 121. And 12 squared is 144. Those are the ones that I told you on your summer packet you need to have memorized. Those are ones you need to know. This one's not really necessary because you would never say, oh, okay, 180 is 1 times 180. Okay, that's real helpful. 1 is the perfect square. You take the square root of 1, it comes out as a 1. You're still left with the square root of 180. You have accomplished nothing. So we don't ever use 1 as a perfect square factor. We're looking to see if any of these numbers are perfect square factors of 180. And you really want the highest one so you can simplify it in one step. But if you do it in 2 steps, that's fine too. So if you don't remember, you can use your calculator to help you find the factors of 180 if you don't know them. Go to your y equals, just like I showed you a while ago, and you're going to put in the number you're trying to find the factors of and divide by x. Look at your table by hitting second graph. Let me go up to the positive numbers here. And we start seeing factor pairs. 1 times 180, that's not helpful, remember, because 1's the perfect square. 2 times 90 is not helpful because neither one of those are perfect squares. 3 times 60, neither one of those are perfect squares. Here's one that works because 4 is a perfect square. Okay, so keep that in mind. I'm going to show you that in just a moment, separating it into 4 times 45. But I want us to keep looking to see if there's more. Here's one right here, 5 and 36. 36 is one of my perfect squares. So let's look at that one. So either one of these will work, but let me show you the difference here. If I do 5 times 36, 36 is a perfect square. I'm going to circle it. So I'm going to take the square root of 36. What number times itself is 36? 6 is. So when I take the square root of 36, it comes out as a 6. The 5 is still stuck under the radical. So this is my simplified form of the square root of 180. Now, if you have did 4 times 45, 4 is the perfect square, not 45. 45 is not on the list. So I would take the square root of 4. What number times itself is 4? 2. So it would come out as a 2, and it would leave under the radical the 45. Well, I didn't get the same answer, did I? And the reason is, this is still not simplified. It would be like if I took, let's see, 6/18 and I reduced it. Okay, if I reduce this by dividing both of these by 2, whoops, you can't see that, can you? If I took 6/18 and I divided both of those by 2, I would have 6 divided by 2 is 3, 18 divided by 2 is 9. Well, I simplified it, right? But not all the way, because this can still be simplified. 3 and 9 both have a common factor of 3. So simplified, 3 divided by 3 is 1, 9 divided by 3 is 3, simplified all the way is 1/3. So this is just like doing what we did here. If you gave me the answer 3/9, well, you simplified it part of the way, you just didn't simplify it all of the way. So this can still be simplified. And so if I went back to my y equals and put in 45 divided by x and looked at my table, I would see I have a perfect square factor right here in 9. So I can separate 45 into 5 times 9. So I would write, don't forget the 2 outside. The 45 becomes 5 times 9. What am I doing? 5 times 9. Which one is the perfect square? The 9 is. So when I take the square root of 9, it's a 3, but outside there's already a 2. And this is multiplication, so that 3 has to be multiplied by 2 to get 6 outside, and then what's stuck under the radical? The 5. Now I have the same answer. Okay, so you want to make sure your answer is completely simplified, not just partially simplified. So you really want the largest perfect square factor, not just a perfect square factor. If you just pick a perfect square factor, make sure it's all the way simplified. Now, another thing that you can do just to make sure that you've simplified it correctly, it might, give you a false sense of security that you got it right if you didn't simplify it all the way. But if you put in the square root of 180 in your calculator and get it as a decimal, well, when you put in 6 square roots of 5, you should get that same decimal, because those are equivalent to each other. This is just the simplified form of that. But like I said, if you put in 2 square roots of 45, you're going to think you did it right because you get the same decimal. It's just this is not completely simplified yet. Now, on number 8, when we go to simplify it, I have a radical in the denominator. I notice in the numerator, though, the square root of 49, 49 is one of my perfect squares. I can take the square root of 49. It's just a 7. So this is the same thing as 7 divided by the square root of 2. But I can't leave that as my answer because remember, it's not considered simplified if there's a radical in the denominator. So we have to get rid of that square root of 2 in the denominator. So we're going to review real quickly multiplication of radicals. If I have the square root of 2 times the square root of 3, then I'm going to multiply what's underneath the radical, and that becomes the square root of 6. Now, if you have 2 times the square root of 3, you can't simplify that. That just stays 2 square roots of 3, because the 2 is not under the radical, so it can't simplify by the 3 that is under the radical. But since both of these are under the radical, I can do the multiplication and get that square root of 6. Now, here's something to be careful about. You can't add the square root of 2 with the square root of 3. You can't say that's the square root of 5 and do that addition. Remember, you can only add and subtract like terms. These are not like terms. This is a square root of 2, and that's a square root of 3, so you couldn't simplify that. If you have the square root of 2 plus the square root of 2, now I can add those because they're both square roots of 2. But how many square roots of 2 do I have now? I have 1, and I'm adding another one, so I have 2 square roots of 2. So that's just some reminders about radical rules. Now, we're going to be using the multiplication rules here to help us rationalize this denominator. So to rationalize it, you're going to multiply by the radical you're trying to get rid of, which is a square root of 2. But I can't just multiply the denominator by the square root of 2. I have to keep this an equivalent fraction, and so I'm going to multiply the numerator and the denominator by the square root of 2. The reason why that's allowed is really, what is this number equal to? Anytime you divide a number by itself, it's just 1. So I'm really just multiplying by 1. So I'm not changing the value of my radical at all. I'm just changing its form. And so now we know when we multiply fractions, we multiply the numerators together.
Could a custodian please report to the library? Thank you.
And ignore that little ink mark. That's not a negative sign. I just accidentally marked there. But this is 7 times the square root of 2. Now remember, you can't multiply that 7 and 2 because the 7 is outside the radical and the 2 is inside the radical. So I'm going to write that as 7 square roots of 2 in the numerator. In the denominator, since these are both under the radical, I can multiply those together. So I can multiply this 2 times this 2, and I get the square root of 4. Now, you might be thinking, but you didn't get rid of the radical. Well, I can now because I created a perfect square. 4 is a perfect square. I can take the square root of 4. What number times itself is 4? Just 2. So now I have 7 square roots of 2 in the numerator and just a 2 in the denominator. So that's my simplified answer. It no longer has a radical in the denominator, and it's completely simplified. Now be careful, you can't cancel these 2's, because this 2's under the radical and this 2's not. If this number, however, had been even, I would be able to simplify those, because those are both outside the radical. So for instance, if this had been the square root of 64, then that would have been an 8. If this had been an 8, 8 divided by 2 is 4. I would be able to simplify those because those are both outside the radical. So hopefully that makes sense on rationalizing the denominator. Just multiply the numerator and the denominator by whatever radical you have in your denominator.